Okay, so this is going to be the first video of this unit. We're going to have a couple more. I think we're going to have probably three total on our first section of Unit 4. Unit 4 is all about linear equations. It's a really big unit with a whole lot of complicated stuff. It's basically algebra. And it's going to span like between 7 and 9 weeks, most likely. So nearly a full quarter. But this first part, we're going to break into a couple of different sections, and then we'll have subunits within the unit of linear equations. So instead of having one big unit test like we did for scientific notation and exponents and rational numbers, we're going to have a bunch of smaller quizzes for linear equations as we go along. We're starting with combining like terms and simplifying expressions, which sounds like a lot of stuff, but it's actually pretty easy for the most part. We get into some kind of complex expressions towards the end, but hopefully what we go over today won't be too bad. So first things first, we need to define some of these things. So some of our vocab for this week, and this goes along with the note sheet that's in the Google Classroom. It's called Simplifying Expressions and Notes, I believe. But basically, we have kind of four main vocab terms. Three of them are here. One of them is on the next slide. First thing is a term. So in math, a term is a component of an equation or expression. Basically, it's a single number or number and variable. So 5 is a term, 5x is a term, 5y is a term, 5x squared is a term. Anything that's just kind of like one contained number. An expression is a mathematical operation that does not include an equal sign but has at least two terms. So like 5 plus 3 is an expression. We can solve it and get an answer. That would be just 8. But you could also have like 4x minus 2 or 5y plus 3x. Those are expressions. Once we throw that equal sign in, that becomes an equation. And we're going to talk about those after this first kind of subunit. A variable is a letter used to represent a number that can change. Now, most commonly in math, we use x as the variable, but this can change depending on what we're talking about, where we are. And then we have a lot of like fancy formulas that have variables that are specific letters. So like the Pythagorean theorem we'll talk about later uses a, b, and c. Basically, for variables, you can use any letter you want except for e and I. You don't want to use e or I because those are both actually numbers. But we're not too worried about that. You're usually going to see mostly X's, but in the IXLs, you'll probably see some other letters as well. So next up, we have this idea of identifying terms. We want to be able to figure out what in this expression are terms. So this whole thing together, is an expression. 4x plus 4 minus 3y. And it's composed of a bunch of individual terms. So if we look at this is a term, this is a term, and this is a term. Now you're going to notice that I circled that minus sign. That's actually because the term here is negative 3y. It's not 3y, and then you just have a minus sign. The term itself is negative 3y. That's going to be much more important when we get to some stuff later. It's not too big a deal right now, but that is worth keeping in mind. So the question is, can we solve this? And the answer is no. There's nothing we can do. We don't have an equal sign here, so there's nothing to solve. So a lot of your answers in this first unit are going to look something like this. You're going to have 5x plus 4 minus 3y, and that's going to be an answer. And students really don't tend to like this. They want to have, equals some number. I need a number as my answer. I can't have a bunch of letters and stuff. And I can't have plus and minus signs in an answer. But when it comes to expressions, we're actually okay with this, as long as it's as simple as we can get. And we're going to spend the whole week talking about simplifying expressions and probably a little bit of next week as well. So we won't worry about that too much just yet. But you cannot get this answer down to just a number answer. It does not work. Now, like terms, this is kind of our last vocab word. Like terms refer to combinations of variables and constants that are similar. So as an example, 3x and 4x are like terms because they both have an x. And really here, the x is what's important. The 3 and the 4 don't really matter. We can have just x, and that's still a like term as well. But we're worried about what variable is part of it. So since they both contain an x variable, they're both like terms. 3x and 3y, even though they both have 3's and they both have a variable, since the variables they have are different, these are not like terms. And then the 3x and 5 are also not like terms, as one contains a variable and the other does not. Same thing with like 3x and 3. Those are not like terms, even though the number is the same, because one has a variable, one does not. So basically, if you have something with an a and something with an a, those are like terms. If you have something with an x and something with an x, those are like terms. You have something that's just a number and something else that's just a number, those are like terms. The question is, why do we actually care about like terms? I'll come back to this in just a second. And the reason is when we're adding or subtracting like terms, they can be combined. And that's really, really important. It's going to help us figure out how to actually simplify some of these expressions and actually be able to do more stuff with terms than we would otherwise. Now, a quick note is that multiplying and dividing like terms is a little bit different. We'll be talking about that more later. It's not going to be something we cover today. But we do want to be careful when combining like terms. The sign of the term, the positive with negative, has to stay with the term itself. So for instance, if we have 3x plus 2x minus 4x, we can't just say, okay, we've got 3x, 2x, and 4x. We combine all those and we're good. We have to actually subtract this 4x. And we'll look at a bunch more examples of that in just a little bit. But going back to the last page, we want to try to identify some like terms here. So they're kind of all over the board. There's a whole bunch of them. I will use different colors to represent different ones. So we'll start with the x's. So everything circled in red here is a like term. I think that's all of them. And then let's see, we'll do black. So anything with a z would be a like term. Anything with a, let's do orange for y. The y is a like term. And then all of the normal numbers. Let's just do like a, so these are all like terms as well. So all the different colors tell us which ones are like terms and which ones are not. And you'll notice that like even though the z doesn't have a number in front of it, it's still a like term with all the other ones. And even though this one is negative, it's still a like term with the other z's. So the sign doesn't matter, the number in front doesn't matter. All that matters is which letter is there and whether or not it has them. Okay. So we want to start trying to actually combine like terms and simplify some expressions. Now, these are pretty easy opening examples, but since you guys have probably not seen a lot of this before, we're going to go over it kind of step by step. So the first thing we need to do is make sure that we have like terms. So 4x, 3x, and 2x, these are all like terms, we can combine them. So then all we're going to do is actually just add the numbers in front the way we would in the formula. So it says 4x plus 3x, that would give us 7x. And we have our minus 2x. 7x minus 2x is going to be 5x. Now you'll notice that the x doesn't go away when we add or subtract it. And that's because of what this is actually saying. So this right here is actually telling us 4 times x plus 3 times x minus 2 times x. Now x can still be any number we want at this point, but it has to be the same number every time we use it. What I mean is we can say x equals 3, or we can say x equals 5. Those are both fine. But when we start plugging them in, we can only use one at a time. So for instance, if we say x equals 3, well, here, I'll just cross this one out. So we're going to say x equals 3. We'll have 4 times 3 plus 3 times 3 minus 2 times 3. Okay, we can solve this out. 12 plus 9 minus 6, which is going to give us 15. Now you might wonder, why do we bother to simplify this if as soon as we plug in a number for x, we can just solve it really easily? And the answer is, well, look at our new expression. We have just 5x here. That's 5 times x, or in this case 5 times 3, which is 15. And this is a lot easier to solve than all of this. So that's why we bother to simplify these expressions here. So again, the simplified expression for this one is just 5x. And the next one, we have 5y minus 3y minus 8y. These are all the same variables. They're all like terms. We can just combine them straight across. 5 minus 2, or 5 minus 3 is 2. Minus 8 gives us, gives us negative 6y. So in this case, we have negative 6y. That's our final answer. That's our expression. Now, again, these are answers. These have letters in them, but we're done. We can't do anything else with this. We can't solve. We can't get a number until we have a value for x or y, which in this entire unit, we're not really going to do. So this is kind of where we stop with these. And this last one's a little different. We have 3x, we have 7x, and then we have minus 3y and minus 4y. So now we have to start actually looking through and doing some different things with these. Now we can combine the x's, so 3x plus 7x, that just gives us 10x. And then we have minus 3y and minus 4y. Now this is part of why I said the symbol really matters here. This is negative 3y minus 4y, which is going to give us negative 7y. And then we can just combine it like this. You might be tempted to say, okay, well, I have 3y minus 4y. That's equal to negative 1y. So there we go, I'm done. But that does not work. You need to make sure you pay attention to the symbol in front of each one. Now, a quick question, and this is more of a side note to introduce what we're going to do next. But we're talking about like terms out of order here. So the question is, does it matter what order we add or subtract numbers in? And this is specifically when we're talking about just adding and subtracting. If we throw multiplication in here, it definitely matters. But with just addition, it actually really doesn't. So if we have 8 plus 3, that gives us 11. 11 plus 7, that's 18. Here we have 7 plus 8, that's 15. Plus 3, that's also 18. So even though we change the order, we still get the same answer of 18. If we look at a more complex example, so here we have 15 minus 9, that's going to give us 6. 4 minus 2, that's 2. We add these together, and we get 8. Here we have negative 9 minus 2, that's negative 11, plus 15, that gives us 4, plus 4, that gives us 8 again. So regardless of the order that I put those in, I still get to the same answer. The important thing here, especially on this last one, is I want to show you this part. So we have this minus 9 here, right? It's after a term. It stays with that negative. When we bring it out to the front, it still has the minus sign in front of it, even though there's no operation here. This 15 started with nothing here, but it's a positive number. So when we bring it out and put it somewhere different, it has to have a plus in front of it. It's really important to keep those signs with the numbers that you're adding together. In an example like this, it's pretty simple. It doesn't make a whole lot of difference in it. It seems easy to do. But when you're doing it with variables, sometimes you can get confused as to whether it should be a negative or a positive. And it's really important to just make sure you have the right symbol with each one. So let's look at these. We have 3x plus 4y plus or minus 7x plus 2y. So what we want to do is first identify our like terms. So we have a 3x, we have a negative 7x, we have a 4y, and we have a 2y. So I can rewrite this as 3x minus 7x plus 4y plus 2y. Now I have my variables together. I can see the signs in front of each one, so I know how I can combine these. So 3x minus 7x, that gives us negative 4x, plus 4y plus 2y, that's going to give you plus 6y. And again, this is an answer. This is as far as I can take this. I can't really do anything else here, so we're done. Next one, I've got 5z. I'm going to circle the z's. We'll still put our underlines under the x's. And then we have this minus 4 all by itself. There's nothing that can combine with. So again, looking at the symbols, we have plus 3x, plus 5x, plus z, and a positive z. So all of our numbers are positive here, except for this minus 4, which we're going to put at the end anyway. So that's fine. And then personally, I just like to go in order of like alphabetical order. So x, y, z. In this case, I would do x first and then z. You can put them in any order you want. It doesn't actually matter. So we have 3x and 5x. That's going to give us 8x. And they're both positive, so we can just add them together. We have a positive z and a positive 5z. Now, this is something I haven't talked about yet. When we have a variable by itself, it's effectively got a 1 in front of it. We just don't need to write the 1 because anything times 1 is itself. So when we have just z, that just means 1z. If we have just x, that's 1x. So when you add these together, be careful. It's 5z plus 1z, which is going to be plus 6z. So that's how we solve the second one. And then the third one, we have 3y, 4y, 2x, 3z, and a minus 22. No. Well, sorry. You'll notice that our x's by itself, there's no other x we can combine it with. There's no other z we can combine this with. There's no other normal number we can combine this with, but we can combine our y's. So 3y plus 4y. Now again, personal preference, I like to write the x, y, z first, so I'll do 2x. It's going to stay there. I have 3y plus 4y. That's going to give me 7y. Plus 3z minus 22. And that's as far as I can take this. Now, this looks terrible, right? There's a whole bunch of different terms. We have 4 terms still. We haven't really done a lot, but we have simplified this as far as we can go. We can't combine our x's and y's or our y's and z's, so we're done exactly where we are, even if my 2's look a little bit like z's. Now, the practice for this first bit, and this is where we're going to end the video here, is IXL V15 and V16. There are going to be some other practices that I put into the Google Classroom. There are going to be a couple that are required of people that are on quarantine. But for the most part, the main focus I want you guys to do is keep up with these IXLs so that when you come back, we can make sure to get you back on your feet and you don't get too far behind. W15 and W16, they're pretty similar. One of them is a little bit more complicated than the other, but they're both practicing this combined like terms thing. A score of 70 on each will get you a 3. A score of 80 on each will get you a 4. The higher you can go on these, the better you understand this content, the easier it's going to be to get you caught up when you get back. So if you're on quarantine, the more you can put time into these and effort into these, the better it's going to be for you. But that's all for this one, so I will see you guys later. If I can get the recording to stop.